Hi, I'm the code architect. Let's explore distributed logs like Kafka and build our own message queue.
All right, let's talk about the magic behind the curtain. You know, the tech that powers pretty much everything from your social media feed to your banking app. We're talking about the distributed log, and today we're going to figure out what makes systems like Kafka tick by basically designing one from the ground up, piece by piece. Okay, so let's start with the big question, the core problem, really. Think about it. We live in a world of just endless streams of data. User clicks, financial transactions, sensor readings from everywhere. It's a relentless, real-time flood. How on earth do modern apps handle all of that without just completely collapsing? So here's how we're going to break this down. First, we'll tackle the core challenge, why these systems even need to exist. Then we'll meet the central hub, the broker. After that, we'll get into the really cool stuff, the secrets to its insane speed and scale. We'll also see how it's built to survive pretty much any disaster. And then we'll wrap up by looking at how this tech is actually changing the world. All right, first stop, that core challenge. The whole secret to handling this massive data fire hose comes down to one really important idea: decoupling. Just think of it like this. We need to create a clean separation between the place that makes the data and the place that uses it. Okay, so on one side, you've got what we call the producer. This is literally any application that's creating data. Could be a web server logging every click you make, a banking app firing off a transaction, or, hey, even your smart thermostat reporting the temperature. They're the source, the ones making all the noise. And then, on the other side, you've got the consumer. This is any app that needs to do something with that data, process it, analyze it, stick it in a database, whatever. But here's the absolute key. The consumer has no idea and doesn't care where the data came from. It operates completely independently from the producer. And that's where the message queue comes in. Its whole job is to separate these two worlds. Let's use an analogy here because it really helps. Think of producers as factories, just cranking out goods 24/7. And consumers? They're the retail stores that need to sell those goods. Now, can you imagine the chaos if every factory tried to deliver directly to every single store? It would be an absolute nightmare. So what's the solution? What sits between the factory and the store? Well, that brings us to the hero of our story, the broker. This is our central logistics hub, our massive warehouse center. Right, so the brokers are the middlemen. They're basically just servers that live between the producers and consumers. Their job? To take in, store, and manage all those messages. Seriously, they are the central nervous system of this whole operation. But you can't just dump everything into this giant warehouse willy-nilly. That would be a mess. Instead, messages get organized into what are called topics. And these are just logical categories. It's exactly like a real warehouse having an aisle for electronics, another for clothing. In our world, you'd have a topic for, say, user_clicks, another for payments. It's all about organization. Okay, so let's peek deeper inside this warehouse. How in the world does the broker handle so much data so fast? Well, it all comes down to a super clever shelving and tracking system. So to get to that massive scale we're talking about, each topic gets broken down even more into things called partitions. You can just think of a partition as its own smaller, perfectly ordered list of messages inside the topic. And this is the secret sauce. This is how the system scales out and handles just incredible amounts of load. And this slide really shows you why that's a game changer. Look, with just a single partition, you create a bottleneck. Only one consumer can process messages at a time. It's like a single checkout lane at a busy supermarket. But when you split it into multiple partitions, now you can have multiple consumers working in parallel. It's like opening up 10 new checkout lanes. Suddenly, you're getting way more work done, and the whole system's throughput just skyrockets. Okay, wait a minute. You might be thinking, with all these parallel streams, how do you keep things in order? And that's a great question. The answer is the offset. Every single message inside a partition gets its own unique sequential ID number. It's basically a tracking code. It guarantees that message's exact place in the line forever. And here's the really brilliant part about that offset. Each consumer is responsible for remembering the last offset it successfully processed. So think about it. If a consumer crashes and needs to restart, no problem. It just looks up its last saved offset and picks up exactly where it left off. This super simple trick is what ensures no data is ever lost or processed more than once. It's totally fundamental to making the whole system reliable. Speaking of reliability, let's dial up the drama a bit. What happens if one of our brokers, one of our entire warehouses just vanishes? Poof, gone. Well, the system has a what-if plan baked right into its DNA. It's the old rule: never put all your eggs in one basket. The system never, ever relies on just one server. To make sure data is durable, that it's never lost, each and every partition is copied or replicated across multiple brokers in the cluster. That means you have several identical copies of your data, all sitting on different machines. So if one machine dies, who cares? The data is safe and sound somewhere else. That, right there, is the heart of fault tolerance. So let's watch what happens when a broker inevitably fails, because it will. The system just automatically detects it. Instantly, one of the healthy replicas is promoted to become the new leader for that partition. And then all the producers and consumers are seamlessly rerouted to this new leader. It all happens in the background with zero human intervention. It's just magic. That's the power of replication. And this design gives you more than just safety. It gives you incredible flexibility. Because as your data volume grows, and trust me, it always grows, you can easily scale the system out. You just add more broker machines to the cluster. The system just expands to meet your needs, no massive, scary overhaul required. Okay, so that's the blueprint. We've designed our system, at least on paper. Now let's bring it back to the real world and see how this exact architecture is powering, well, pretty much everything. And I mean it when I say everywhere. These systems are the absolute backbone for processing real-time website activity, for handling millions of financial transactions every second, for collecting data from a gazillion IoT sensors, and for building the modern event-driven microservices that pretty much all our favorite apps run on. But of course, a system this important isn't something you can just set up and forget about. Oh no. Teams are constantly watching it, monitoring key metrics. They're looking at stuff like message latency. Basically, how long does it take a message to get from A to B? And crucially, consumer lag, which is how far behind the consumers are from the live data. If that lag gets too big, it's a huge problem. It means your users aren't seeing things in real time, and the whole system starts to feel slow and out of date. And look, with this much data flying around, security is obviously non-negotiable. You have to lock this stuff down. And that boils down to 3 core things. First, authentication, verifying who is connecting. Second, authorization, controlling what they're allowed to do or see. And third, encryption, protecting the actual data, both when it's in motion and when it's just sitting there on a disk. So, let's do a super quick recap of a message's entire journey, from start to finish. 1, a producer writes a message. 2, the broker grabs it, slaps an offset on it, puts it in a partition, and copies it to other brokers just to be safe. And 3, a consumer reads that message, does its thing, and then saves its place by noting the offset. That's it. Simple, elegant, and unbelievably powerful. So there you have it. From decoupling massive systems to making real-time analytics possible, the ideas we've covered today, they are the absolute bedrock of modern data architecture. So the only real question left is, now that you know how it works, what are you going to build with it?
Like, share, and subscribe to my channel for more AI insights. I'm the Code Architect. See you soon.